This video shows introduction of beam pattern in 1x4 tiling for PAAM using FutureAccess Type C.
Hello, my name is Yujiro Tojo from Fujikura Limited Japan. Fujikura has developed a 28 GHz phase array antenna module, PAAM. In November 2023, we released new type of PAAM as FutureAccess Type C, which is a higher output power version than conventional PAAM. I will introduce the over-the-air measurement setup using PAAM and instruments. PAAM is an 8x8 array antenna with a total number of 64 elements. There are three key features in FutureAccess Type C PAAM. First, PAAM is total modules integrated as antenna, beamformer IC, frequency converter IC, bandpass filter, combiner, and splitter. Second, EIRP is 48 dBm at EVM 3% using 256 CAM bandwidth 100 MHz modulated signal. Third, we can customize configuration of elements as 64 to 256 elements or more. By tiling them for 64 elements as a unit, PAAM can transmit larger power. I will introduce the 4 PAAM settings. These multiple PAAMs are configured 1x4 tiling and 8x32 elements. Total number of antenna is 256 elements. 4 PAAM is installed on a rotating table. The distance between 4 PAAM and 4 antenna is 6 meters. At this size, the required far field distance is approximately 6 meters. In this time, we perform direct far field measurements. This analog chamber size is 8 by 8 meters to create a setup that can measure larger arrays. A 4 antenna is set up on the receiving side that can measure both H pole and V pole as dual polarizations simultaneously. We have used a Rohde Schwarz vector network analyzer ZNA67. ZNA is connected to TX side PAAM and RX side 4 antenna. The key features of ZNA are 4 ports plus LO ports, built-in LO signal output, built-in phase coherent. Source coherent mode is very important function for obtaining more accurate phase and gain data. We have demonstrated beam pattern measurements of 1x4 tiling for PAAM using time sweep mode in ZNA. This time sweep measurement is very fast to check the patterns.
Hi, I'm Takahito Shoji from Fujikura Limited Japan. Now, we will demonstrate beamforming of 1x4 tiling PAAM by using ZNA. The total active number of elements is 256 elements. At first, we will show the beam pattern theta minus 60 degrees. We set ZNA time sweep mode and control the rotary table from minus 90 degrees to plus 90 degrees. Please wait for 21 seconds. Yes, it is finished, and we can check the beam pattern easily. At beam direction theta minus 60 degrees, the maximum EIRP is 58 dBm. Next, we will show the beam pattern theta equal minus 30 degrees. Please wait for 21 seconds. Similarly, we can confirm the beam pattern by waiting for 21 seconds. Next, the beam pattern indicates theta equal 0 degrees. As you can see, maximum EIRP shows 60 dBm and the side lobe level is over 10 dB, so the side lobe is suppressed greatly. Now, all the measurement is finished. We can see the 5 beam patterns at theta minus 60 degree, minus 30 degree, 0, plus 30, plus 60 degree. When we see EIRP at theta 0 degree, it shows 60 dBm. On the other hand, at plus minus theta 60 degree, its EIRP is 58 dBm. At the both direction, the drop is 2 dB, which is slight drop. So PAAM can show beam forming at wide range without decreasing EIRP. And when we see beam width, at theta 0 degree, it shows very narrow beam width. This indicates that tiling PAAM can show accurate beam forming. Furthermore, we will show the two-dimensional power map created by sweeping the beam direction of PAAM. We set PAAM and horn antenna oppositely. The PAAM position is rotated somewhat to the horn antenna position. At this condition, we will show whether this PAAM can search the horn antenna position by sweeping the beam direction. As a result, a larger power distribution can be seen at theta 45 degree and phi is 315 degree. So PAAM could have searched the horn antenna. If the PAAM is at the base station and the horn antenna is a mobile phone or other access points, this beamforming demonstration is very effective. PAAM shows very accurate beamforming.
I will summarize these results and mention conclusion in this video. Our concept is tiling of PAAMs to large array. First, we have demonstrated beam pattern measurement of 1x4 tiling for PAAM at 256 elements. At theta equal minus 60 to plus 60 degrees, EIRP shows maximum 60 dBm at theta equal 0 degrees. And EIRP shows maximum 58 dBm at theta equal plus minus 60 degrees. This result shows relatively small power drop at theta equals 60 plus minus 60 degrees. Second, we have demonstrated 2D power map showing with sweeping several beam directions. This result shows precise beam control in any spatial directions in the range of 60 degrees. And also show effective demonstration of positioning detection accuracy of user equipment.